What the James Webb Space Telescope found, something no one expected, was what appeared to be city lights in space, roughly 7 trillion miles from Earth. This astonishing discovery has sparked wonder about the possibility of life on other planets. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, and observed it emitting strangely bright lights. This has led scientists and the public alike to question what could be causing these lights. Could these be artificial lights resembling cityscapes? Could this be a sign of intelligent life beyond Earth? The James Webb Space Telescope, JWST, has detected strange phenomena in space, leading scientists to investigate further. People have long hoped to glimpse life outside our solar system, and any evidence supporting that dream has been welcomed. Recently, scientists experienced a major breakthrough when the JWST detected what appeared to be solid proof of living organisms in space. While scanning space and transmitting critical data back to Earth, the telescope captured unusual lights seemingly coming from Proxima Centauri b, lights that resembled those of a distant city. The idea of an alien city existing far from Earth has shocked scientists, leaving many in disbelief. If these lights do indicate intelligent life, it suggests that advanced societies could be operating in ways very different from our own, and we're only now beginning to detect them. NASA engineers, amazed by the observation of these lights 7 trillion miles away, can't help but wonder how long they've been there, waiting for us to develop the technology to see them. David Kipping, a scientist at Columbia University, explained that Proxima Centauri b is difficult to study due to its unusual lighting patterns. Most rocky planets absorb sunlight and emit infrared radiation, but Proxima b does not follow this pattern. Its infrared behavior diverges significantly from that of its parent star, Proxima Centauri. The JWST, however, is ideally equipped for this study due to its advanced infrared imaging capabilities. By analyzing Proxima b's unique heat signatures, scientists can learn much about its atmosphere and possibly determine if it is habitable. The James Webb Space Telescope excels at detecting the faintest rays of light in the vastness of space, making it the perfect tool to confirm whether the reported city lights on the night side of Proxima b are genuine. Man-made lights, even extremely faint ones, can be detected as long as they fall within a frequency range 1,000 times smaller than sunlight. Interestingly, the planet's day side is covered with solar panels that gather the star's energy and reflect some of it back into space. Proxima b has a day-night cycle similar to Earth's, which occurs over 11.2 Earth days, and this regularity allows for thorough observation. If Proxima b has an atmosphere, the next step is to examine its chemical makeup to determine whether it can support life. Gases like oxygen, water vapor, and methane are key indicators of habitability. Scientists must carefully record and study light rays as they pass through the planet's atmosphere to identify these elements. Despite its strengths, the JWST is not very effective at detecting bound oxygen, one of the most definitive signs of life. But it can search for other markers like ozone, which also indicate biological activity. The JWST is limited in its ability to examine only nearby potentially habitable worlds. However, astronomers anticipate that future ground-based telescopes, such as the Extremely Large Telescope, ELT, expected to launch in 2028, will offer more detailed atmospheric analysis of distant exoplanets. While we wait for the ELT, the JWST remains an essential tool in our ongoing exploration of the universe. Despite some limitations, this telescope may still transform our understanding of planetary exploration. One of the primary goals for future telescopes is to block out bright light from a planet's host star, allowing better visibility of the planet's faint reflections. Techniques like using internal masks or large external star shades, which act like sunglasses, will enable better study of planetary atmospheres and habitability. However, distinguishing between gases produced by living organisms and those generated by natural processes like volcanic activity remains a major challenge. Still, the search continues, driven by humanity's relentless curiosity. The JWST's work on exoplanets gives us an early glimpse into future scientific discoveries. Despite decades of exploration, we have yet to find definitive evidence of extraterrestrial life, but the search continues. Humans have long wondered whether we are alone in the universe. Today, scientists use the James Webb Telescope to search for signs of life and even evidence of alien civilizations. This search isn't new. Since 1984, the SETI Institute, Search for Extraterrestrial Intelligence, founded by Jill Tarter and Thomas Pearson, has been scanning the skies for radio messages from space. Radio waves are particularly promising in this search because they travel great distances without significant loss. Though SETI has yet to find such signals, Jill Tarter remains optimistic. She believes that technological advancements and global collaboration could eventually yield results. NASA has recently suggested that the JWST may have observed city-like lights on a planet near Earth. This telescope is a cutting-edge tool designed to uncover hidden details about galaxies, stars, and planets, including their origins. The JWST uses specialized cameras and filters to separate light into specific wavelengths, enabling the study of the chemical and physical composition of distant celestial bodies. One of its missions is to look for tiny signs of life in exoplanet atmospheres. For example, scientists have identified more mass in the universe than previously believed, especially within massive galaxies, reshaping our understanding of cosmic structure and evolution. 20 years ago, little was known about planets outside our solar system. Now, astronomers have identified over 4,000 exoplanets orbiting distant stars, illustrating just how far science and technology have come. NASA estimates that these discoveries are only a small fraction of what remains to be found. Though the search has spanned decades, scientists remain hopeful that alien life may be found on planets we've never visited. One breakthrough came when the Galileo spacecraft visited Jupiter. Its spectroscopic equipment detected a signature suggesting that plants could exist on other worlds, a biosignature called the Vegetation Red Edge, VRE. This marker identifies alien life by studying how light reflects off surfaces. The JWST aims to use the VRE to investigate potentially habitable planets by carefully mapping their orbits and atmospheric conditions. When sunlight passes through a planet's atmosphere, atoms and molecules absorb specific wavelengths, creating a unique spectral fingerprint. Spectroscopic analysis can identify these patterns. If the JWST detects light from stars passing through a planet's atmosphere, it can determine the chemical makeup. Planets similar in size to Earth may have carbon dioxide, nitrogen, and oxygen, key ingredients for life. However, the absence of unusual chemicals might hint at unknown forms of life or technology. Artificial compounds like chlorofluorocarbons, CFCs, used in industrial applications could indicate the presence of advanced civilizations. If the JWST finds such synthetic chemicals in an exoplanet's atmosphere, it would offer strong evidence for the existence of intelligent life beyond our solar system. This would open new doors to studying the atmospheres of distant planets and exploring the possibility of civilizations outside the Milky Way. Life beyond Earth might not resemble anything we know. For example, extremophils, organisms that thrive in harsh conditions, challenge conventional thinking about where life can exist. Extremophils can survive in environments with temperatures as high as 250 degrees and pH levels below 3. Their resilience proves that life can persist in extreme environments. The vast size and diversity of the universe mean that our search for life must be open-minded and wide-ranging. Earth-like planets orbiting Sun-like stars are logical starting points, but even red dwarf systems deserve attention. These cooler, longer-lived stars offer a wide range of evolutionary possibilities. One of the JWST's exciting discoveries is the TRAPPIST-1 system, which includes a dim red dwarf star and 7 rocky, Earth-sized planets. 3 of these planets appear to be in the habitable zone, meaning they might support liquid water. Although TRAPPIST-1's star is cooler than our Sun, it provides a gentle light that could still foster life. JWST's detailed observations have confirmed that this system is about 41 light-years away in the constellation Leo.Ward. Howard, a NASA Sagan Fellow and lead researcher at the University of Colorado Boulder, emphasized how the JWST has enabled scientists to explore exoplanets in unprecedented ways. He highlighted the importance of studying stars to understand their planetary systems. Among the many stars in the sky, Proxima Centauri stands out as the closest to Earth at 4.25 light-years away. Despite its nearness, it's so dim that it's barely visible at night. To be habitable, any planets orbiting Proxima Centauri would need to be at least 20 times closer to their star than Earth is to the Sun. On August 24, 2016, astronomers made a major discovery, a planet 1.3 times Earth's mass in the star's habitable zone. Proxima b orbits just 4.6 million miles from its star, receiving enough light to keep temperatures in a potentially livable range. However, its proximity exposes it to harsh conditions, including strong solar winds that could erode its atmosphere.